bad word there. Okay, so I'm recording now. Okay, so graphically we solved and we got a coordinate pair, place where the graphs cross. So for this, when we do it algebraically, I prefer algebraically, just because I like that exactness. So systems, we used to do 3 variables, and I really enjoyed that. This is my favorite lesson of like everything. We used to do 3 variables, now we're just down to 2, but you have to solve for both variables. Like that's the whole thing. So there's 2 ways to do it. You're either going to solve by substitution or you're going to solve by elimination. Now, if you remember grade 10, you did this in grade 10. But you did it for linear. You didn't do it for obviously quadratic. So again, your solution should be a coordinate pair. You should have values of x and y. Really, it doesn't have to be x and y. It could be a and b or whatever. Okay, so substitution. What do we do in substitution? Maybe it is. I don't know, but I got nothing. Okay, all right, we're back. Maybe if I stick my hand in the way. Okay, so substitution is exactly what it sounds like. We're going to take one equation and we're going to substitute it into the other one. So we're going to put it inside. So you're going to have to rearrange one of the equations to a single variable. So step 1. So do the one that makes the most sense. It doesn't matter which one it is, but it has to be one of them. Now, both of these, like what pops in my head right away, is if I have a linear, that's a much simpler equation than the quadratic. You guys agree with me? Much easier, we know how to graph it. So I'm going to rearrange this one to equal a single variable. So what variable do you think I'm going to get it to equal? How come? It's already single. It's done. I don't have to do a lot of math to it. The less math you do, the less switching around and dividing out, the better. So this is going to be y equals negative 3x minus 9. You guys would agree with me if I switch that around and change the order? Easy peasy, right? Okay. I'm working here. Okay, so we've rearranged equation 1. We're going to take that. So what you've just done is you've made an equality statement. That's what an equal sign means. Wherever I see y has a value of negative 3x minus 9. Like y equals 2, right? And just substitute 2 in everywhere you see the y. We're not that fortunate. It's not just numbers. But so where we see this y, we're going to put in that. So it's got to go into the second equation. So rearrange one equation to a single variable. Okay, so you're going to sub into the other equation. That's really important. You can't sub back into the equation you just changed around. It's got to be the other one. So we're going to have 4x squared minus x plus, I like to put it in brackets just for now because it's like I'm plopping it right in, negative 3x minus 9 equals a negative 9. And the reason why I like to put in brackets and like just plop right in is because if this was a subtract, then in my next statement I would change the sign. Does that make sense? Like I do it as 2 different steps. I know some of you will be able to do it all as one step, but sometimes slowing down isn't a bad thing. So I'm going to have 4x squared minus x minus 3x minus 9 equals a negative 9. Okay, how would I solve for x? What pops off the page at you right away? I I need it to equal 0 because I'm going to do what? Factor or use my quadratic formula, right? I know that right away because I have an x squared. So I'm going to have 4x squared minus 4x equals 0. Yeah. Okay. Where did you get your force? So, this doesn't have something on the end of it. This doesn't have a constant on the end of it. That's what I'm trying to say. So I'm not going to be able to factor it like a trinomial, but I am going to be able to common factor it. So what can I take out of there? 4x. So if I did if I just stick my head into the sunshine, it works. If I take out a 4x, I'm left with x minus 1. You've got to leave that placeholder there, right? Like it's the act of dividing 4x out. If you just put x, you're not going to get the correct answer. Okay? So if you take this whole thing out, you have to leave a placeholder for it. Because if you multiply this back in, it should look exactly like that. And if you take that out, if you multiply it back in, you only have that. And that's not equivalent. So now that we're going to set them both equal to 0, both factors equal to 0. And so the x equals 0, and that'll be x equals 1. So before I figure out, because I'm not done yet, because I haven't solved for the y values, right? Because I need a coordinate pair. I need full variable solve for. How many solutions does this system have? 2. If I have 2 x's, that means, like, think about it pictorially in your head. That means if I were to graph these two things, that linear equation would cross the parabola in 2 spots, one when x is 0, one when x is 1. Right? So you anticipate that there's 2 solutions here. So now we're going to, now that we've solved for x, we need to find y. Okay, so we're going to find y when x is equal to 0. And you can sub into either equation. You can sub into the parabolic one, or you can sub into the linear one. I'm going to sub into the quadratic. I want you guys to sub into the linear. And you should end up with the same answer. What my quadratic was, that would be helpful. Did you guys get -9? Yeah. So the point is that that's the point is that's the whole point. Is that that is a solution because both equations cross that exact point. So it doesn't matter which one you sub into. My advice to you is sub into the less complicated one. If there's one with fractions and things like that, I may not pick that one to sub into. But you guys have been doing this, like, we did this in the rational number units. 2 unit, 2 letter, 2 numbers that add up to 16. The difference of their reciprocals is 2/9. Solve for the numbers. That's a system. It's a more complicated system, but it's just a system. So what's my other solution? So, what was it? I'm going to sub it back into the quadratic. You get -12. Yeah. So you could write the solution as a coordinate pair, or you could write it as 2 variables. Right? I tend to go with this one when I'm solving algebraically, because this one's linked to a graph, or it might be mistaken as a domain. Right? So it asks me to solve for the variables, so I solve for 2 sets of them, because I'm going to have 2 solutions on that graph. Easy peasy? Okay. Substitution. Big fan of that one. Elimination. Please note that it's the exact same question. Okay. So elimination is the act of eliminating a variable. But you have to be strategic in doing this. So, what variable would you like to get rid of by either adding or subtracting these two equations? Okay. Okay, it's easier to get rid of y, because this is a 3x, that's a single x. Right, I just got to subtract it. So, I will also tell you why I would want to get rid of that. I hate to kick you ladies out on the last day, but I'm not above that. So I like when I do this, when I'm either adding or subtracting them, I like to line them up, like with the same variables right underneath each other. I leave spaces when they don't have the same variables. So obviously I can't remove an x squared, because I can't do anything to that. I could eliminate the x, but if I took the x out, and I do that by timesing this one by 3 and then adding them together. I just for a second with that. But how would I solve that? Like how would I solve an equation with an x squared and a y in it? The answer is you can't, right? So what I need to remove is the y, because then I have x squared and x's, and we know how to deal with that. We know that we're going to factor. All right. So, am I adding or subtracting these to get rid of the y? I'm going to subtract them. All right. So 4x squared minus nothing hopefully gives me 4x squared. I have negative x minus 3x. Negative 4x. Y minus y. 0. Do I need to write in the 0? No. And then negative 9 minus a negative 9. Does that look familiar? Right? That's exactly what was on the page the last time. We know we have an x squared is equal to 0. We can solve, so we're going to have 4x equals 0, x minus 1 equals 0. The y for this one was a negative 9, and the y for this one was a negative 12. Right? Because we did that last time. I don't think I need to show you the substitution again. Bring it back and solve for the other one. I never use this method. I don't know why. I never think to go this way, but this looks pretty easy. Like I've done a lot less work on this one than I did on the substitution, but for some reason my head always goes to substitution. I don't know why. You will not be asked to solve a system in a specific way. Like I won't say solve by elimination. I will say solve the system, and it will be up to you to choose which method you prefer. Okay, okay? It's all on you guys. All right, so these are my favorite kind of questions. These are my favorite kind of questions, and they will be on the exam, and they will be on the test. And they showed up in chapter 6. Where else did they show up? I don't know. I feel like they showed up in another chapter already. So these are my favorite kind of questions, and these are probably your least favorite kind of questions. So somewhere we're going to meet in the middle, and you're going to love them eventually. Okay, so it says determine two integers. Look at the language, read the question. I'm yelling at my grade 10 yesterday to read the questions. Integers. What kind of numbers do we know integers are? Positive, negative, whole numbers. So if you get something that's a fraction or a decimal, 1, go back, check your math. 2, if that's really what you think is the answer, you're going to reject it because it's a rational number, not an integer. And that sometimes happens. Sometimes I'll put whole numbers up here. And so you might get a negative in your solution and you would reject that because that's not a whole number. That makes sense, everybody? So we'll look at the language, what it's telling you. Okay, 2 sentences, and I bulleted them. So what do you anticipate? 2 equations. You need 2 equations to solve any system. So probably equation 1 most likely equation. Okay, 14 more than twice. Okay, maybe we should label our first integers. So my first integer, what letter do we want to use? Second integer? Perfect. Okay, we'll spice it up with two different letters. It's going to confuse us already, why for sure. Okay, so we labeled our integers. We know there's something, we just don't know what they are. 14 more than twice the first integer. So let's start here. Twice the first integer, what does that look like? 2x. And then I'm going to go back and do the 14 more. Plus 14 gives the second integer, so equals a. Are we good with that? Could you do that on your own? Yeah. You totally could. Yeah, you totally could. Second integer increased by 1. A plus 1 is the square of the first integer, so equals x squared. So, you want to do elimination or substitution? How come? Because this is already rearranged for you. And plus my mind only works in substitution. I don't do elimination for some reason. So I'm probably going to jump right to substitution. You're not wrong if you do elimination. Like we're going to get the exact same answers. But I'm going to do substitution. So wherever I see A, that's going to go in for it. So I've got, and again, I'm going to use brackets just because I like to indicate that it kind of got plunked in there. So I'm going to have 2x plus 15 equals x squared. Now you have to use your math, all the skills that you have to now solve this. So we are going to do what? We're going to factor it, right? So if we're factoring it, it has to equal 0. I'm probably going to bring the left-hand side to the right-hand side because my x squared is already positive. I hope you guys have tricks like this that you're thinking of when you go to move stuff. What happens when I'm talking, right? All right. Let's factor that. 5 3. What kinds of 5s and 3s? And if that's still messing with you, we're looking at the factors of negative 15 that add up to a negative 2. So negative 5, positive 3, add up to negative 2. Could I use the quadratic formula? Factoring isn't my strong suit. 100% you can, right? Yes, it will be a little bit more math, but if you really struggle with factoring, we're solving this case, so you can go right to the quadratic formula. You've got to figure out a strategy that works for you, because I don't want to see you guys spending 800 years trying to factor something. You're going to spend so much time trying to factor something that you could have done less work doing the quadratic formula in the scrap. Are those both integers? Yes. Am I done? No, because I have to solve for A, right? So when x is 5, what's A? 24. Are you sure? Did you do that in your head? So for those of us who are just catching up, substituting 5, I'm going to assume into the first equation because it's nice and simple. So 2 times 5 is 10, 10 plus 14 is 24. I probably wouldn't do it into this, but this would be 25 minus 1, which would also be 24. And then if I put in negative 3, so I have a negative 6. So this is set 1. This is set 2. So when you guess and check, you know, you guys always ask me, can I just guess and check this? Chances are, though, when we guess and check, we're probably going to find one answer, and we're done. right? So if you're guessing and checking, you're probably pretty proud of yourself to get the answer. But you may not go the next step to find the second solution if there is one. Right? Doing it algebraically is going to get you to this. Okay. Is that it? You have to show me your trial and error of guess and check. You have to show some evidence.
So, I mean, like, let's consider x equals 2 of 5. And then something we will get the answer that this is correct. I mean, if I'm guessing and checking, what should I show my math?
Then you need to guess and check two numbers right away. And you've got to put them into both equations to see which one works. Chances are you're going to work in one equation. Maybe that first one first, but you have to guess and check both answers. You wouldn't guess 5 and be able to find 3. You'd have to guess and check 5 and 3 as a pair, which I think is exponentially harder.
I mean, if I check 5 or 3,
Okay.
and then I can consider
Right, and then, yeah.
Another number that
Yeah. But you have to show me the trial and error. Okay. So this one's a quadratic system. Again, with a quadratic solution, if I eliminate the x squares, or if I substitute in for the x squares, rearrange the equation to x squared, I'm going to be left with something x plus y or x minus y equals a constant. And I can't solve an equation with two different variables in it. So when you have this, you're always going to be trying to get rid of your y's so that you can solve an x squared and x and a constant. You can do that through factoring. You can't solve this and you can't solve that. Anytime there's an x or y, you can't do that. So looking at these two, like I said, math lesson, maybe you pick you up. Okay. So looking at these two, I think I would go to elimination. Anybody? No? So would I add or subtract them? Subtract them. So I'd be subtracting because a negative minus a negative is going to eliminate that y. I'm just looking at the variable I'm trying to eliminate. I really don't care what happens to the other stuff. I'm figuring out whatever I have to do to get rid of that. So 6x squared minus 4x squared should leave me with 2x squared. Negative x minus a negative 4x is going to leave me with positive 3x. The y's, they should go away. If they don't go away, you've done something incorrectly. And then I've got 5. Right? Yes? You good? So it's an x squared. So I know that it's going to, be equal to 0. That's a negative 5 there. Complex factor. You guys remember how to do this?
it will be
5.
2 and a
So first thing I got to do is I got to multiply those together, right? I get a negative 10. So I'm looking for the factors of negative 10 that add up to a positive 3. So this time would be a positive 5 and a negative 2. That's opposite. But it's not as easy. I can't just drop it in. So I'm going to have 2x squared minus 2x plus 5x minus 5 equals 0. Look at my first two. What am I common factoring out? 2x. So the 2x comes out. I'm left with x minus 1. Remember, you need that placeholder there. And then we'll look at the second pair. What am I taking out? What kind of 5? Positive 5. So that's gonna be plus 5 gets taken out. So notice I put in the plus, like an add 5. And I'm left with x minus 1 again. These two things have to be exactly the same. Yes, yes. Okay. Okay, so my first factor is the x minus 1. So I've taken that out. What's left? 2x plus 5. You guys are really good at not dropping equal signs. Very proud of you. That's going to be a benefit when you get to grade 12. So I'm going to have x equals a positive 1 and x equals a negative 5 over 2. So how many solutions do I have for this one? 2. So now I got to do the y's. Anybody see the problem? Not a problem. It's going to take a little bit more thinking. First one's nice and easy. If I put a positive 1 in here, I get 6 minus 1 gives me 5. So I'm going to have 5 minus y equals negative 1. Y equals 6. You guys agree with me? That's nice. I can do that in my head. Well, I kind of wrote it down. Does it matter which one I substitute into? No. Why did I pick the first one?
Because it's easier.
Oh, I just picked it because it was the one to solve. I don't know. Yeah, like maybe it's easier. I don't know. Okay, so now, now we've got 6 negative 5 over 2 squared minus a negative 5 over 2 minus y equals, what is it equal?
Negative.
Negative what? Thanks. So I've got 6 times 25 over 4 plus 5 over 2 minus y equals a negative 1. Could I do this? Are you guys okay if I do this? Anybody know why I do that?
Because
Then I got a common denominator, so life's a little bit better. And I can do 3 times 75 and 3 times 25 so I got 75 over 2 plus 5 over 2 minus y equals a negative 1. So I have 80 divided by 2. Can I simplify that? See, and this is why I like solving algebraically. I don't have to graph that. I don't have to worry about my increments on the graph. I don't have to do anything. And that's where we're at. Could you guys do that with fractions successfully? Okay, I would challenge you, and you guys really don't like challenges, I would challenge you to start using fractions in a situation like this, instead of going directly to decimals, instead of going to negative 2.5. I know that it's easier and you can punch it into your calculator, but it's good to practice. And that's it. That concludes grade 11 pre-calc.